Samba praise for your praise. Oh Lord God, we thank you for the gift of this day. We thank you for everything that you help us to be with in life. Oh Lord God, we pray that you guide us through this lesson so that everything that we are taught may help us in our life and all that we are to do in our UNEB examinations. We pray this through Jesus' name. Amen. In the name of the
Amen.
Father, and of the Son, and of the Holy Spirit.
Amen. Thank you so much, Rogers, for the word of prayer. And I am praying that even you where you are, it stabilizes such that we can learn. I know we may be having some rains where we are, but we pray that the network is very good such that we can be able to have this lesson run. Today, we are going to look at the Maclaurin's series, and this is going to be our heading, the Maclaurin's series. So let me ask you to write our heading for today, and then we are going to start off. The Maclaurin's series is what we are going to look at in our session today. Okay, so we are going to start now. Now, our learning outcome by the end of this session is that you must be able to approximate. The major thing is here, this is what you need to know, that you must be able to approximate functions to solve advanced calculus problems and real-world scenarios, particularly in engineering and physics. Now, this particular series we are going to look at, it is one that helps us to estimate a function. Like when you have a function, let me say you have a function like cos of x. What series can you use to estimate this kind of function? So that is what we are going to be looking at today, and we are going to concentrate at that area. So when we talk about the Maclaurin's theorem, what is it? Now, when we talk about the Maclaurin's theorem, is that series, is that function that has an expansion of the different sums of the derivatives that we can use to obtain a series. And how is it defined? We define the Maclaurin's series using this kind of expansion, whereby f is our function, and when you see f prime is the first derivative, f prime prime is the second derivative, f prime prime is the third derivative. So that is what we are going to look at today. And I'm going to ask you, you first write it down. You first write how we define a Maclaurin's series. Yes, so let's first have it put down in our books. So the Maclaurin's series, okay, when you finish, you let me know. After writing it down, you let me know. Okay. Okay. People are finished. Okay. We are going to first continue and I explain further. Now, what does a Maclaurin's series do? Number one, that it is the one that we can use to approximate functions. Whenever you have a function that is not easy to integrate, you can use this kind of series to make an approximation for that particular series. So it makes integration and differentiation much easier. Now, more so when you are dealing with differentiation from first principles, there are times whereby you need to make an approximation of a given series. So we use the Maclaurin's series. Even when it comes to numerical methods, when we are solving problems, more so when we are dealing with what we call transcendental functions, then we can also apply this Maclaurin's series. When we talk about a transcendental function, is that kind of function that cannot be expressed as a finite algebraic expression involving only polynomials. So that's what we call a transcendental function. So you cannot express it as a finite function. An example I can give you is when you have an exponential of x. When you look at this kind of exponential, you cannot express it like in terms of a finite series, like saying 1 maybe plus x, that the answer gives you this. So since you cannot express it, then it means that for you to be able to estimate it, we shall use the Maclaurin's series. When it comes to logarithmic functions, such as the natural log of x, also that one, we cannot express it. Now, transcendental functions, all those functions which when you draw, you see continuity. Those are what we call transcendental function. Can you put in the chat some of those functions you think that when you draw, you'll be able to see something continuous, like you see those curves that are continuous that are not ending. Those are what we call the transcendental functions. Can you put some functions you know in the chat? Any that you think when you draw, you come up with a curve, you come up with something. Those are what we call the transcendental functions. So in order for us to estimate such functions, it means we can be able to use the Maclaurin's series. Things such as, let me say, sine of x. That one is called a transcendental function. So those are the different functions we can call. Cosine, very good. When you look at the cosine of x, yes, those are transcendental functions. So for such functions, we estimate them using the Maclaurin's series. The likes of maybe sine inverse of x, all those ones are called. Then also when we are interpreting and analyzing the behavior, we can as well use the Maclaurin's series. So in simple terms, a Maclaurin's series helps us to simplify those complex functions, making them much easier for us to do the calculations, but most especially when we are dealing with differentiation and when we are dealing with numerical analysis. So that is where we use mainly this kind of expansion. So we are going to go on and look at our first example. And when you look at our first example, they are asking us to find the Maclaurin's expansion for cos of x. Now, always the first thing you have to do is write down what the Maclaurin's theorem tells us, or series. So it tells us that whenever I have a function f of x, this is the same as f of 0 plus x, f prime of 0 plus x squared, f double prime of 0 out of the 2 factorial plus x cubed, f double prime of 0 out of the 3 factorial, then plus tan tan tan. Yes. So that's how we define a Maclaurin's series. And now your task, whenever you are handling such, is to identify what is my function. After identifying what your function is, then do you know how to differentiate? If yes, then it means you are very good to go. Now, for such a case, what do we have? We have our function f of x equaling to cos of x. Now, since they want us to find a Maclaurin's expansion, what does it mean? It means we need to find what is f of 0. We need to find what is f prime of 0, what is double f prime of 0, what is double prime of 0. So I'm going to first deal with the first one, f of 0. What does it mean? I'll come here and say f of 0 will equal to cos of 0. And here, avoid assuming many times some students just think that cos of 0 is also 0. So here, we shall end up with a 1. Then we go to the second one. The second one, they want f prime. So that means you have to now to differentiate. So I know f of x is equal to cos of x. Now, if I'm to get f prime of x, when we differentiate cos, we end up with negative sine of x. Now, if I'm interested in f prime of 0, I'm going to come and say f prime of 0 will equal to negative of sine of 0. So when you say sine of 0 is 0, so you get negative 1 times 0, which gives us a 0. Then from there, I continue. I go to the next one, f prime prime. So we have our f prime of x equaling to negative sine of x. Now, f prime prime, it means I'm going to say f prime prime of x will equal to, I differentiate. It will be negative cos of x. But I have to find f prime prime of 0. So I'll come and I say now f prime prime of 0 will equal to negative of cos of 0. Then place your calc. What is cos of 0 is 1. So I have negative 1 as my answer. Then I go to the next one, f prime prime of 3. So we have our f prime prime of x as negative cos of x. Now, if I'm finding f prime prime, I go on and say f prime prime of x will equal to, I go on to do my differentiation. When I differentiate, I will get negative of sine of x. So negative of sine of x will yield for us a sine of x. Then after that, go on and now find out what is your f prime prime of 0. So this will be sine of 0, which also gives us a 0. So that's how we go on and expand. I can continue and find what is f of x. Now that is f prime 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 of x. I come here, I differentiate again. I'll end up with cos of x. Then what is f prime prime of 0? It is going to give us cos of 0, which is going to give us a 1. Members, let me know through the chat. Are we on the same page? Are we leaving someone behind? Gilbert. Okay. Anyone that we are leaving behind, same page? Yes, same page. Pardon, sir. Okay, I'm going to repeat same page, same page. Okay. Just for those, I'm going to repeat Kalito. When we are expanding, expressing something in a Maclaurin's series, this is the kind of, let me say, the series we follow when we are expanding. Whenever you are given any function, for this case, our function is cos of x. That is your function, cos of x. Now, our Maclaurin's expansion will always tend to 0. So, it occurs at that point when x is equal to 0. So, in this function of yours, where there is x, you're going to be substituting here with a 0. And then you place your calculator. That cos of 0 gives us a 1. Then to get the second term in this series, remember we have terms, first, second, third, fourth, like that. To get the second term, differentiate with respect to x. So you come and you say f prime of x. So you ask, when I differentiate cos, what do I get? That I will get negative sine of x. Now, when you get negative sine of x, you ask yourself, now what is that function at x is equal to 0? So you substitute and end up with negative sine of 0, which is 0. Then you continue to the second, you differentiate again. You keep on like differentiating. But whatever function you differentiate, you substitute the value of x as 0. So that is what we do for these functions. Now, after that we have obtained everything, we are going to keep on substituting. Substitute. So now, in order for me to substitute, I'm going to come and say, now our function f of x will equal to our f of 0, we had our answer as 1. Then I go plus x times f prime, we got 0. So this is going to be x times 0 plus our x squared times f prime of 0. We got our answer as negative 1, but everything divided by the 2 factorial plus our x cubed. But our x cubed, we got our answer as 0, so I will multiply times 0 divided by 3 factorial plus the next one is going to be x power 4. X power 4 times what did we get for f prime of 4? It was a 1 divided by the 4 factorial plus Now this series is a continuous one. It is an infinite series. It does not end. So when we reach at this point, what are we going to do? We can now simplify. This is 1. Here we end up with a 0 because x times 0 is a 0. And then I go to the next one. I'll have plus, but this is x squared times negative 1 gives us a minus. So this is going to be minus x squared out of the 2 factorial. The next one gives us a 0. Then the next one is going to give us x power 4 out of the 4 factorial. Then plus, and here always we put 3 dots to show the continuity. Now what we have here is our expansion for f of x. So it is the one that shows us that cos of x is the same thing like 1 minus x squared out of 2 factorial plus x power 4 out of 4 factorial, then plus So always you put the continuity to show that it is still continuous. In case you want, you can as well even place the factorials and you put those different values. Members, are we on the same page up to that point? I want to know whether we have understood up to that point. Okay, Linda says yes. Okay. Okay, same page. Okay. So let's put it down and then we'll look at another example. But the only thing you need to know, do I know how to differentiate? Once you know how to differentiate, every other thing will be very clear. Okay, let me pick on Bettina. Yes, Bettina.
Good morning, sir.
Yes, morning, Bettina.
So I don't know if I'm not the one understanding the thing, but that answer you gave, is it an approximation? Is it that you finished to differentiate? What is it? Kind of
Oh,
failed to understand the
yeah,
theorem.
okay. Bettina, it is an approximation. We are asking ourselves that if I don't have the cos x, what else can yield the same answer as cos of x? Are you getting it?
Yes, so in case maybe you're asked to differentiate, can you then
Hmm.
continue to differentiate that answer you got instead of differentiating cos x?
Oh, now this one being an approximation, an approximation is not an exact value. Yet in many cases, when we are using or when we are working, we want to get an exact answer. Now this is just a numerical approximation that can yield the same answer. Now for such approximations are very useful whenever we are dealing with things from first principles. Take an example. In case you are dealing with a series and you are differentiating, let me say, cos from the first principles, you can reach somewhere and then just quote that cos x is equal to this. But that is from first principles. Maybe I will show you an example where we can apply such. I will use one of the functions to show you where we can apply such a concept.
Yes, teacher.
Hmm. But let me as well show you that it is the same thing. Let me use the graphical approach. The graphical approach will give us the real picture of what you are asking. Take an example. When you look at my screen, this is my graph. So I'm going to draw the graph of cos x. I know people know how the graph y is equal to cos x. That is how the graph looks like. Now, if I am to draw this series we have obtained, the series we have obtained is y equals to, the first value was 1 minus, we got x squared out of the 2 factorial, then plus x power 4 out of the 4 factorial. Now, what are you noticing? Remember, this one is a continuous thing. It is continuous. But when you look at these graphs, Bettina and everyone, you notice that our graph, this graph of ours we are obtaining, this is the, oh, let me change the color. I don't know if the members are seeing it. Let me change the color such that that graph can come out very well. Now, the red graph is the curve we are obtaining, is this curve we are expanding. But because we have not finished the values, you can easily notice that this curve is going to fit exactly how the cos curve fits in. Now, as we continue with other values, it will come also and it fits itself and it fits itself. So for smaller values or for small approximations, more so when you are dealing with a smaller approximation near zero, you can notice that the curve fits very well. But this curve here converges. As you continue, it keeps on putting itself onto the cos curve. That's what we are saying. And the more expansions you do have, the more accurate you are to the answer. So as you continue, let me just check here. Just imagine here we had continued. I think the next one is going to be minus x power 6 power 6 over 6 factorial. Then plus, I think it's going to be x, that was a minus plus x power 8 out of, oh, what's happening? Yeah, but you are going to notice that as you continue, it keeps on putting itself there, it puts on. So the more values you are going to have, the more you'll find that your series converges at that particular point. So it goes on converging up to when you reach a particular point. So that's what we are going to look at. So it's just an approximation. It's just an approximation. Bettina, is that fine? I don't know whether Bettina is okay with that. Okay. Bettina, hope it is fine. You have understood what we are saying. Members, are we good to go? Is everyone fine with that? Or there is a question? Yes, Samuel?
So good morning.
Yes, good morning.
So my concern was like when we are dealing with the derivatives, like how many derivatives can I use? Like maybe can I have like as many as I can, or I have a limit to where I can end?
Okay. In case the question is open, in case it is an open one, at least get three. At least three are enough. Is that fine?
Oh,
Like 3 terms, not 3 derivatives. I'm saying 3 terms. Like 3 terms, Get at least
Yeah.
3 terms. 1, 2, 3 terms. In case the question is open. But in some questions, they will restrict, they will say up to the power of 4. But in case the question is open, make sure you get at least 3 terms. That is terms. So the number of derivatives, we may not determine how many you are going to move. It will depend on the function. But the number of terms, at least make sure you come up with 3 terms.
Okay, sir.
Okay. So members are saying we are good to continue. Some questions will be open, others they will be a bit closed. An example is for this particular question. When you look at it, you notice that they have restricted us, that they want us to end when in x power 4. Now, members, first write your Maclaurin theorem. So, right, series. So I'll write it as f of x will equal to f of 0 plus x, f prime of x plus x squared, f prime prime of 0. Don't forget, just substitute the 0. 0 out of the 2 factorial plus x cubed, f prime prime of 0 out of the 3 factorial. Then do not forget to show that it is continuous. And I want you always to notice that what is down here corresponds to this. What is down here corresponds to this as well as the derivative. So take note of that. Here we don't just put a 1 factorial, but this one also corresponds to the 1 and then the 1. Even here we don't put the 0 factorial. Yes, that's why here we don't put x power 0. Okay. Now, after that, we get our function. So for this case, we shall say that our function f of x is equal to the natural log of 1 plus x. Now, your task is substituting. That is the first thing. Substituting and see what do you get when you do the substitution. Now, if we are substituting, we shall say f of 0. What shall we have? We shall have natural log of 1 plus 0, which will give us a natural log of 1. If you place your calculators, what is natural log of 1? What are you getting for your natural log of 1? It is everyone getting 0? It is a 0. So here we shall say that this one is a 0. After that, go to the next one. We have our f of x is equal to the natural log of 1 plus x. Now, we get the first derivative, f prime of x. Remember, we say that at this point, I do expect everyone to know how to differentiate. So we say that when we are differentiating natural log, I will differentiate this. And when I differentiate 1 plus x, I'll get a 1. After, divide by the original power by the original function you differentiated, which was 1 plus x. Now, after this, we are going to go on and ask ourselves, what is our f prime of 0? So that means we shall say 1 out of 1 plus 0, which will give us a 1. Then we continue to f prime prime of x. Now, when you look at this function here, when you look at this function very well, it is up to you to use which approach you want to use. This one, I can decide to write it if I want. I can decide to write it in this format of 1 plus x, everything power negative 1. Then when I'm differentiating this, I know I can use the chain rule. I drop the power, I'll get negative 1. I reduce the power by 1, I'll get negative 2. Then I multiply times what I have inside, which is 1. So I end up getting negative 1 out of 1 plus x, everything squared. Alternatively, another person can say, for me, let me use the what? Let me use the quotient rule. You say this is your u and this is v. Then you go on and say my v is 1 plus x times my du, which is 0, minus my u, which is 1, then times this, which is still 1, divided by 1 plus x, everything squared. So you end up with negative 1 out of 1 plus x squared. Another person could say, let me use the natural log. And then you say that my y is 1 out of 1 plus x. Then you say this is natural log of y equals to the natural log of 1 minus the natural log of 1 plus x. Then you say this is 1 out of y equals to 0 minus 1 out of x. This is with the y, this is with the x. Then when you cross multiply, you get your dy dx equals to negative 1 out of x times our y, which is 1 out of 1 plus x. So you end up also with negative 1 out of 1 plus x, everything squared. So use any approach of your choice as long as you know how to differentiate. So let me hope that is okay. So here you are going to allow me that for me I'll write negative 1 out of 1 plus x, everything squared. So after that, we get f prime of 0, 0. So I'll say f prime prime of 0 will equal to negative 1 out of 1 plus 0, everything squared. And this one will give us a negative of 1. Then we go to the next one, f prime prime of 3. So members, can I stick to one rule, chain rule? Is that okay? Or, but use any of your choice, Use any of your choice. Still, when I go to f prime prime of 3, I'm going to say f prime prime of 3 of x. It is up to you. Remember now your f prime prime of x is the same as negative 1 into 1 plus x, everything power negative 2. So if I'm to get f prime prime of x, I will drop the power, I'll get 2 into 1 plus x. Then I reduce the power by 1, which is negative 3 times what is inside. So I'm going to end up with 2 out of 1 plus x, everything power 3. So that is our derivative. So here I will say 2 out of 1 plus x, everything power 3. Then I go and I say, what is f prime prime of 0? So this is going to be 2 out of 1 plus 0, everything power 3, which will give us our 2. Now you continue. Remember they told you up to x power 4. Now when you look at x power 3, we are still on 3. So we have to do one more derivative. So I'll come and I say, what is my f of 4, 4? Now you come back, I'm starting from here. So you notice that what we are going to differentiate is the same as 2 into 1 plus x power 3, but negative. So when I drop the power, I'll get negative 6. Then I reduce the power by 1, which is negative 4. When I differentiate what is inside, I'll get 1. So I end up with negative 6 out of 1 plus x, everything power negative, power 4 now. Now, you go back again and you write that derivative, that my f, let me draw a line here, that now my f prime 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 of x is the same as negative 6 out of 1 plus x, everything power 4. Now, what are you going to do? Substitute in what is your f of 0. So now I'll come and I say f1114, 0 is equal to negative 6 out of 1 plus 0, everything power 4. And I end up with negative 6. So can you raise up your hand in case you have a question? In case there is something you have not obtained very well, kindly raise up your hand such that we can help you from this point. Anyone that is a bit stuck? Anyone that is not getting how we are getting things? Okay. Yes, Shadow.
Good morning, sir.
Morning.
I came late, but I thought to understand where the 1 plus x is coming from. Like from f prime 1, x equals
Like,
to
are you
1
saying
over
this?
x. Yes.
When we are getting f prime, we differentiate once. So, do you remember how to differentiate our natural log?
Yes.
So that's what we have differentiated. When you differentiate 1 plus x, what do you get?
1 plus x equals to 1.
1. So that's the one we have here. Then after we divide by the original function. So this is what we obtain for our first function of the derivative.
Okay. Thanks.
Okay. Okay. The same issue. Okay, hope you have seen, yeah. So we are just differentiating, but you need to know here the techniques of differentiating. Okay, now after obtaining all, you come back here and then you substitute. Substitute the first one, the second, the third, the fourth, the fifth term. Yes, Rogers.
Yes, teacher, I'm not understanding from that part of factorizing the third time
The
from
third
where
term.
you're getting that. Where are you getting that 2 over 1 plus x there, yes.
Remember, our second derivative was this, negative 1 out of 1 plus x squared.
Yes.
So, do you know the chain rule?
Yes, miss.
So this becomes negative 1 out of 1 plus x power negative 2. Now, the chain rule, when I'm to differentiate this, I can have this power dropped. So I have negative 1 times negative 2, which gives us a 2. Now, this
2.
power, I reduce by 1, which gives us negative 3. Times.
You,
When you
you
come
get a
here, are
1.
you seeing this part?
Yes.
You differentiate what is inside, you get 1. So at the end of the day, you have 2 into 1 plus x power negative 3, which is the
Yes.
same as 2 out of 1 plus x, everything power 3.
Okay, miss. Do you do the same for the first, for the...
Yes. The same for the fourth like that.
Okay,
Mhm.
thank you.
Okay. All right. But in case that kind of differentiation is a bit tough, then you go on and use the quotient rule. Yes, Mebra. Yes, you write up to the term that has been indicated in the question. So here we shall come and say f of x is equal to, our first one was a 0, so here we have a 0. The next one was x f prime, our x was 1, so allow me to write x plus, the next one was x squared of f prime prime, which was x squared times negative 1 out of 2 factorial, then plus the next one is x power 3 times the 2 out of the 3 factorial, plus the next one we got negative 6 out, sorry, x power 4 out of the 4 factorial, then plus other terms. So that means here we can have x minus x squared out of the 2 factorial plus our 2x cubed out of the 3 factorial minus x power 4 out of the 4 factorial, then plus plus. Now, at this point, you can reduce these factorials, more so if you find yourself having the numbers. So here we shall have x minus x squared out of 2 factorial is the same as 2. You place on your calc. Someone take for us a photo of the calculator and you show us where the factorial is. So here we get 2 plus 2x cubed divided by, when you place your 3 factorial, you end up with your 6 minus 6x power 4 divided by our 4 factorial. So when you place your 4 factorial, you end up with a 24, then plus other series. Now at this point, this is where you can reduce that by 2, 1, by 2, 3. By 6, 1, 6 goes into 24 4 times. And therefore, you can go on and say now, this is the same as x minus x squared out of 2 plus x power 3 out of 3 minus x power 4 out of 4. And then you say plus and other terms. So that is our function. Members, are we on the same page? Okay, Gilbert says yeah. Okay, yes. Okay. In case you feel you're a bit stuck, kindly let us know. Okay, Ashley. Okay, Matthew. Okay, are we good to continue? Okay, same page, same page. Okay, good to go, good to go. Okay, good. Okay, okay, okay. Can I first give you a number to try? Now, we are going to look at this particular item whereby they have given us to find the Maclaurin's expansion for cos squared of x up to the power of x power 4. Hence, write down the expansion for sine of x squared to powers of x power 6. Now, what do you need to know? One, you need to remember that if they ask you to use the Maclaurin's expansion, they have asked you to use the Maclaurin's series, that's what you are supposed to utilize. And how does it state? It tells us that f of x will equal to f of 0 plus our x, f prime of 0 plus our x squared, f prime of 0 out of the 2 factorial plus and other digits that come. Identify what is your function. Now, there are two approaches that we can use. The first approach we can use is us dealing with this function the way it is. That your function here is cos squared x. The second approach, someone can decide to say, but my function of cos squared x is the same as cos x times cos of x. So someone can first obtain cos of x and then the cos of x, and then you deal with that. Alternatively, someone, if you are very good at differentiation, you can just go on the way with cos squared of x. Now, which approach am I going to use? Allow me to use the first approach, whereby I'm going to obtain the individual cos of x, and after that, I do the multiplication. Why am I preferring this one? Many of us are very familiar with how to differentiate cos of x simply. Compared to this one, because here, I know some of you know that this will be 2 cos of x then times negative sine of x. If you know how to do what? To differentiate, it becomes very easy. But you notice that as you keep on going up, you notice that now here, I have to apply the product rule. So you first keep these two. Then you say, I keep cos x, I differentiate sine of x. And then I keep sine of x, I differentiate cos of x, negative sine of x. So you notice that as you continue working out, things are going to become a bit more. So you may notice that even when you look here, you notice you have negative 2. This is going to be cos squared x minus sine squared of x. You keep on differentiating, so things are becoming more and more. So for such a case, it is better you first deal with one function and then you multiply. Hope you have got my background, why I want to use the first one. So I'm going to say that let my function f of x equaling to cos of x. That is my function that I'm going to use. So I will say that my f of x is equal to cos of x. Now I first obtain f of 0 Lillian. So I say f of 0 will equal to cos of 0. And cos of 0, members, is equal to 1. I go to the next one, f prime. Now, if I go to f prime, I'll say that what is my f prime of x is equal to, I differentiate cos x, which gives me negative sine of x. But what is f prime of 0 is equal to negative sine of 0, and f prime of 0 will give us a 0. I go to the next one, f prime prime of x. F prime prime of x, when you differentiate sine x, you get cos x. So you shall have negative cos of x. Get your with 0. So it will give you negative cos of 0, which gives us a negative 1. That is f prime of 0. Continue getting f prime 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 of x. Remember, we stopped at negative cos. So when I differentiate, I'll end up with negative of sine of x. So f prime 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 of 0 will give us sine of 0, which is 0. Continue f prime 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 of x. Remember, this is a plus sine of x. Differentiate, you end up with a cos of x. Now get f prime 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 of 0, which will give you cos of 0, which is equal to 1. Like that, like that. Then after, I'm going to substitute here, and I say now, my f of x will equal to f of 0. We obtain our answer as 1. When you look at the next one here, f of prime, we got 0. So we are going to ignore that. We go to the next one. X squared of f was negative. So I will say minus x squared out of the 2 factorial. Then the next one, x cubed, we go to 0. I eliminate that. I go to the next one. Next one, I'll have plus x power 4 out of the 4 factorial. Feel free to first write these expansions. This is x cubed f prime prime of 0 out of 3 factorial plus x power 4 f of pam 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 of 0 out of the 4 factorial, then plus plus plus. Now, here, this is our expansion we are obtaining, plus plus plus. And this is f of x was cos x. That means that when I have cos of x, my answer is the same as that. Now, since they asked for cos squared of x, it means that I'm going to get these functions, I multiply them twice. That is the meaning. So I'm going to come and I say, but what am I interested? I'm interested in cos squared of x, which we know that is the same as cos of x times cos of x. So you get the two series. I have the first series, which is 1 minus x squared out of the 2 factorial, then plus x power 4 out of the 4 factorial plus. And this one, I'm multiplying it with 1 minus x squared out of the 2 factorial, then plus x power 4 out of the 4 factorial, then plus plus. Members, are we still together up to that point? Okay, paper saying yes. Okay, yeah. Now, we are going to multiply. Now, when I'm multiplying, this one affects everything this side. So, when I multiply through at first, you notice I'm going to get 1 minus x squared out of the 2 factorial plus x power 4 out of the 4 factorial. That is when I multiply the first. When I go to the second, I multiply this by the whole of this as well. So, when I'm multiplying for the second one, I want you to observe. This minus x squared multiplies the 1 first here. What will I have? I'll end up with minus x squared out of the 2 factorial. This one multiplies again the next one. So it will be plus x power 4 out of, here I have 2 factorial, 2 factorial. I can first keep them, 2 factorial, 2 factorial. Then this one multiplies again the next one. So it will be minus x squared times x power 4 out of the 2 factorial, the 4 factorial. Now, after that, I go to the next one. I'm multiplying. I'll have this multiplied by the whole of this. So the whole of that, it means that I'm going to have plus x power 4 out of the 4 factorial. I continue this times the next one. I'll have minus x power 4 x squared out of the 4 factorial, the 2 factorial. The next, when I put the next, is going to be x power 4 times this. Now, x power 4 times x power 4, you notice that it will be plus x power 4 x power 4 out of the 4 factorial out of the 4 factorial. Now, since they told us that we end at x power 4, at x, up to powers of x power 4, it means that you notice that x power 4 is already x power 8, so this one is not needed. X power 4 x power 2, this one is already 6, this is not needed. X power 2 x power 4, this is 6, this is not needed. Now that means that the only things that are relevant to us are those in x power 4. So that means this one is very important. This one is needed. This one is needed. This is okay, 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 and then this is okay. So we are going to write them as 1 minus x squared out of the 2 factorial plus our x power 4 out of the 4 factorial minus the x squared out of the 2 factorial plus x power 4 out of the 2 factorial, then plus x power 4 out of the 4 factorial. Now, we are going to like to collect like terms. We are going to collect like terms. But as you are collecting like terms, since I know we are not used on how to deal with the factorials, better you first simplify them, no problem. So this is like having 1 minus x squared, 2 factorial is 2, plus this is going to be x power 4 out of, when you check out your 4 factorial, 4 factorial is the same as 24. So here you can put 24 minus, this is x squared out of 2 plus, what is 2? When you have 2 factorial times 2 factorial, you end up with a 4. So this is going to be x power 4 out of 4, then plus x power 4 out of the 24. You collect like terms. Now here, you have this term here, and you have this term here, or in x squared. So it's like having negative x squared out of 2 minus x squared out of 2. Your LCM is 2. So that means here you're going to have negative x squared minus x squared. Negative x squared minus x squared yields us a negative 2x squared out of 2. Now these two can cancel and you remain with negative x squared. So you're going to allow me to say that our first term is going to be 1 minus x squared. Now after that, look at those ones in x power 4. When you look at those in x power 4, you are going to ask yourself, I have this, this, and this. So what personally I always do, I can just come and I say, since x power 4 is this x power 4 out of 24 plus x power 4 out of 4 plus x power 4 out of 24. So here, still your LCM is 24. Now you do the same. Here we shall have x power 4 plus 24 divided by 4. You get 6. So I'll have 6x power 4 then plus x power 4. When you simplify, you have 1 plus 6 plus 1, which is equal to 8x power 4 divided by 24. Then you can reduce by 8, 1. 24 goes into 8, 3 times. So here we shall have 3 times. So that means that I'm going to have plus x power 4 out of the 3, then plus other series that can come after. So that is how you simplify up to the power of x power 4. Members, is that fine? Are we on the same page? Anyone that is lost? Enid, Matthew, are we together up to that point? You may first ask. Yes, Dr. Jimmy.
Good morning, Master.
Morning.
Now, Master, there we will have cos squared x. Why didn't we differentiate the cos squared?
I said that option is very fine. That option is very fine. You can use that option or you can break it. But like I said, that option favors people who are mastered very well differentiation, because you are going to reach a point where you have very many sines and coses in your function. Yet here, when you separate, you are dealing with just one function.
Okay, Master. I had missed out that one, that point.
Okay. Why did he cancel out the first? Now I said the first, the reason why we removed these ones, our answer here, our question told us that we stop at x power 4. But when you look at x squared x power 4, you end up with x power 6. You notice? Okay, I can add it. You get x power 6 here. As well here, you get x power 6. Even here, you get x power 6, which is already beyond our x power 4. That's why we ignore them. Okay? No, the question is not yet done. We are still continuing. Yes, Matthew.
Good morning, sir.
Yes, good morning.
Sir, I would like to know on this point of multiplying, why you cancelled these x squared times x to power 4 from that
Okay, let us
add.
include them. I'm going to include them. Allow me to include them. So this one, let me include them. Allow me to include them back. No problem. So this one is going to be minus, hope you can notice, x power 6, 4 plus 2, divided by 2 factorial and 4 factorial. When you multiply the 2, what do you get?
I think
You
you get
get
8.
48.
4.
Then minus x power 6 out of 48. Then plus, this last one was 4, which was x power 8 out of 4 factorial times 4 factorial, which is 576. Now, on this next step, negative 148, negative 148 minus 148, you end up with 24. I don't know that you're saying you are aware of that.
Yes.
Is that okay?
Yes, sir.
So now that is how you deal with the search.
Okay. Thank you, sir.
All right. So if we are to, okay. So that is 48. You have to open this, and this is this. Then this and that. Okay.
Yes.
Opt is fine. Members, is it okay? I wanted to include the one in power 6 as well. Okay. Let me know whether we are on the same. No, the question is not yet done. The question is not yet done. Okay. I'm going to include this one of 6 as well. I'm going to include, and when you look at the one of 6, we have negative x power 6 out of 48 minus x power 6 out of 48. Now here, your LCM is 48, so you have negative here of x power 6 minus x power 6, which gives you negative 2 x power 6 out of 48. Then you can reduce by 2, 1, 48 goes into 2, 24 times. So that one can be, here we can have, since it is negative, it will be minus x power 6 out of the 24. So that is in case you have added it on there. But for the first part, since they told us up to x power 4, that's where we end. We end here. This is our cos squared of x up to that. Now, then the next one told us that, hence write down the expansion of sine squared x to power of x power 6. Now that is what we are going to find. Now, whenever they tell you hence, it means that they do expect you that start from the previous, and then continue from there. Now, what does it mean? It means that we are going to start from there and check out, is there any identity that can relate the first one to the second one such that we can be able to obtain sign? Members, which identity is that we can use? Which identity is that we can use? Which identity is that we can use? Okay, I'm looking through. Okay. Ayobo?
I think we're going to use sine squared x equals to 1 minus cos squared x.
Okay, good. So that is the identity we are going to use. So we are going to come here and now say from our identities that sine squared of x plus cos squared of x is equal to 1. But since they want us to find our sine squared x, we make it the subject. So we shall say that sine squared x is going to equal to 1 minus cos squared of x. So this is going to be equal to 1 minus. We go back to our series, we obtain, and what was the series? It is here, 1 minus x squared. Okay, go back. It was 1 minus x squared, and then, x power 4 out of 3 plus x power 4 out of 3. Now, when you read the question very well, they told you up to x of power of x. Up to x of power of x. So, it means that you go a bit further to include the other series that we had eliminated, such that you are very, very safe. So we are going to include that series that we did eliminate. Hope that is okay. So it was x power 4 out of 24. So I'm going to come here and then say minus x power 6 out of 24. Then plus, okay, other digits that come. Can we first finalize it on our own? Finalize it, and then we see what you have. Finalize it, and then we see. Okay, hope members have finished. Where does the 24 come from? Okay, Ms. Meta, I'll go back there. But if you check out very well, I told you from here, Ms. Meta, check here, that this one was negative x power 6 out of 2 factorial, 4 factorial. 2 factorial is 2 times what is 4 factorial? Then you place your calculator. 4 times 3 times 2 times 1, which is 24. So 2 times 24 gives you 48. So this means it is negative 6 out of 48. But also there's another component here that has the same. So that one was also minus x power 6 out of 48. So when you add this and this, that's where we got negative 2x power 6 out of 48. Then by 2, 1, by 220, 24. So that's where it came from. Okay, perfect. I've seen the answers in the chat. I've seen our answers in the chat. So from the chat, so members here, you open very well. So when you open, you have 1 minus 1. Don't forget this negative affects everything. So we shall have plus x squared minus x power 4 out of 3 plus x power 6 out of 24, then plus. So 1 minus 1 is 0. So for this one, we shall end up with x squared minus x power 4 out of 3, then plus x power 6 out of 24, then plus plus. So that is how we deal with such a series. Let me hope we are very good to go. Okay. Yes, Julie?
Good morning, sir.
Good morning.
Like teacher, from the question, they said that we end up to x power 4, but I'm seeing we are having up to x power 6.
Okay. Are you saying the what?
Yes, I'm
Eh,
seeing
Hmm.
the answer is up to x power 4.
Up to x power 4. Though here, like when you check here, you notice that this is what we are getting. Up to x power 4 for the first one. So we end here for cos squared x. Is that okay?
Yes.
Yeah. Though here, I think members allow me also to tell you that we can, this expansion for x power 6, allow me that we end also at 4 for one reason. Why? When you look at this expansion, if we continue to get another expansion here, you notice, I don't know whether you are noticing, because here I want to bring it to your attention. You notice that if I'm to continue here to get another expansion, there is something we are going to add on to this series. When you go back, when you look here, there is another expansion we have to add on here. So I want you to take note of it. That if you continue differentiating this cos x to get another series, let me, you'll notice that you have something like x power 6 out of, what is 6 factorial? I want you now to allow me this question. We are going to end at power 4 because there are more series here we have to generate. Let me say, when we go to f of power 5, 1, 2, 3, 4, 5. You notice, I want to first show you something. When you go to f power 5, you are going to notice that you are going to end up with a negative of a sign of x, which will be 0. If I go to f of power 6, power 6, power 6, I think it's going to be like this, power 6. You notice that I'm going to end up with a negative of cos of x. Now for that one, if you substitute in your 0, you notice that you have negative cos of 0, which gives you a negative 1. So what does it mean? It is going to give us a negative 1, so it means we shall have negative 1 out of 6 factorial, but this is going to be x power 6. Now here, there is another one we can add. So when I add on minus x power 6 out of 6 factorial, also this side, I have to add on minus x power 6 out of 6 factorial. What does it mean? When you look at this x power 6 and I multiply it times 1, there is an additional term I'm going to have here of minus x power 6 out of 6 factorial. Members, are you able to see that? When you multiply by 1, first let me know whether you are seeing that. Are you able to see it? Yes. Now, if you have x power minus 6, it means here, when I multiply here, it's going to give me this. But anything that is going to come after this is going to be x power 8, x power 10, and the rest of that. So here, when we are deriving this series here, we are going to add on, I want to bring it to your attention that here, we are going to add on. Let me first clean my screen again. Here, we are going to add on another series that we have it is a minus, right? It was a minus, yes. So we are going to have here another series of minus x power 6 out of 6 factorial. So here we are going to add on minus, okay, now it will be a plus, right? It will be a plus of x power 6 out of the 6 factorial. Even here, we shall add on that series of x power 6 out of the 6 factorial, of which now we can now write what is 6 factorial, which when now we compose x power 6 out of 24 plus x power 6 out of 720. When we compose that, 1 out of 720 plus 1 out of 24, I don't know whether members are following up, or is it getting a bit confused, or it is clear? Is it clear to everyone or not yet? I want to first know whether that is clear. Is it fine? Confused. People are confused a bit. Okay, allow me. Can we just stop at x power 4? I changed it to x power 4. It is well. It is well. We can put it to x power 4 because I want you to observe that there is another series that comes in here that you need. Even here, when you put in x power 6 out of the 6 factorial. In fact, this is a minus. This is a minus. And also here, like if you add on x power 6 out of the 6 factorial. Remember this and this multiplies. So this multiplies everything. So there is another series that comes after. No, confused. Not yet. Not yet. Okay. Okay. Allow me that I create a screen and I first show you, because for this series it is continuous. Allow me to create some 2 screens now, and I throw more light on it. Allow me to throw more light on it. Okay, I want to do it, and then I show you what is going to happen. More so now for that one, because remember, we had our f of x equaling to cos of x. You're going to allow me to first differentiate as many times as we can. So the first one, f prime of x, you end up with negative sine of x. F double prime of x, you end up with negative cos of x. F of double 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 prime of x, you end up with this is sine of x. When it comes to 1, 2, 3, 4 of x, you end up with cos of x. When you go on to the fourth one, you end up with this is cos x. It gives you a negative sine of x. When you continue, no, this is number 5. When you continue to the 6th one, you end up with negative cos of x. Now, what is your f prime of 0? Here, you end up with 0. Here, you end up with a 1. Here, f prime of this one, of double prime, you end up with negative 1. F of double prime of 3, you end up with a 0. F of double prime of 4 of 0, you get a 1. Here, of double of 5 of 0, you end up with a 0. Here, of this of 0, you end up with a negative 1. First, is that okay, how I have differentiated it? Members are saying yes, fine. Now, we go back to our expansion, that f of 0 plus our function f of x is f of 0 plus f prime of x plus x squared, f prime prime of x out of the 2 factorial plus x cubed, f double prime of x out of the 3 factorial plus and other things. So when we substitute in, you'll see that for f1, we have 1. The next one, we have 0. I go to the next one, which is going to be minus x squared out of the 2 factorial. I skip number 3. I go to number 4. So number 4 is going to be a plus x power 4 out of the 4 factorial. I go to number 6. I skip number 5. I go to number 6, which is going to be x power 6 out of the 6 factorial. Then plus other series that come after. Now, if I'm getting my x squared and I'm multiplying, it means that I'm going to have 1 minus x squared out of the 2 factorial plus x power 4 out of the 4 factorial minus x power 6 out of the 6 factorial. This one, I multiply it again with its thing, x squared. Here, remember, it is continuous. Out of the 2 factorial plus x power 4 out of the 4 factorial minus x power 6 out of the 6 factorial plus. Now, this one here, this one will multiply everything. So when you multiply by everything, what do you get? You get the exact thing. So I have 1 minus x squared out of the 2 factorial plus x power 4 out of the 4 factorial minus x power 6 out of x factorial. Then, after that, I go to this next one here. I multiply everything, this x squared. So when I multiply by the x squared, now I'll have x squared times 1, which will give us a minus. Hope you are not seeing. I have minus x squared out of the 2 factorial. This x squared multiplies this x squared, which gives us minus x power 4 out of the 2 factorial 2 factorial. This x squared multiplies the other 4, which is going to be minus x squared x power 4 out of the 2 factorial, the 4 factorial. This x squared multiplies the 6, which is x power squared x power 6 out of the 2 factorial, the 6 factorial. I go back. This x power 4 multiplies the 1. Now I'm having this x power 4 multiplying everything. Let me first speak. Yes, Jimmy.
Master, I think you made a mistake there.
Where?
Where we multiply the x squared out of 2 factorial times negative 2x squared out of 2 factorial. I think it becomes positive.
Where?
Negative, let me see, 1, 2, 3, 4, 5, 6. The 60th term.
1, 2, 3, 4, 5, 6 here.
Yes.
Okay. This, are you seeing this negative? And this negative, we get a plus. Okay, thank you. So here, there is a plus. Okay. So we continue. So I was on this x power 4 with everything. So that one, we get x power 4 out of the 4 factorial. Multiply the next one, you get x power 4, x squared out of the 4 factorial, the 2 factorial. Multiply the next one, you get x power 4 out of the 4 factorial. Yeah. X power 4 out of the 4 factorial. Multiply the next one, you get x power 4, but this is a minus. And the next one is going to be a minus. Then it's going to be a minus x power 4, x power 6 out of 4 factorial, 6 factorial. Now, we go to the next one. This one here now, we multiply. Now, when you multiply it with everything, you'll have minus x power 6 out of 6 factorial. Multiply it with the next one, which is going to be a plus x squared out of the 2 factorial, x power 6 out of 6 factorial. Plus, now the ones I want to extract, allow me to first end there with expansion. Now the ones I'm interested are the ones of x power 6. So this is 1. This is another one. This is another one, and this is another one. So you are noticing them, there are 6 of them. So when I pull them out, what am I going to have? I'm going to have negative x power 6 out of 6 factorial minus x power 6 out of the 2 factorial, the 4 factorial, minus x power 4, x power 6 out of the 4 factorial, the 2 factorial, minus x power 6 out of the 6 factorial. Now, I'm going to simplify to remove the factorials, so I'll have minus 6x out of 6 factorial is 720. Here, 720 minus 6x power 6 divided by 2 factorial, 4 factorial, which gives us, was it 48? 2 factorial times 4 factorial, which is 48 here, 48, minus x power 6 out of 48, minus x power 6 out of 720. Remember, simplify for me that and tell me what you get. Simplify and tell me what you get. What do you get when you simplify all those ones? Simplify and tell me what you come up with. Thank you, Ayobo. So you come up with negative 2 out of 45 x power 6. Now, that is what I wanted to bring to your attention. I don't know, members, are we together? Members, is that fine to everyone? Kindly let me know in the chat. Are we together how we have come up with that value? Okay, Ronald says now together. What about the rest? Are we together up to that point? Good to go. Okay, yeah. So when I come back here, for this particular series of hours, let me see whether I can clean my board. Oh, okay. You are going to allow me to first do something. Keep, then. Okay, I have nothing to do. Okay. Okay, I've been able to remove it. Now, when it comes here, where we are finding our sine squared of x, it means that our sine squared x will equal to 1 minus the cos squared x, which is going to be 1 minus. Remember, our cos squared, we had gotten 1 minus x squared, so I will say 1 minus x squared plus x power 4 out of 3, power 4 out of 3. Now, our sixth term is this term minus 2x power 6 out of 45, then plus. Now, when we come to subtract, we have 1 minus 1 plus x squared minus x power 4 out of 3 plus 2x power 6 out of 45. Then other terms can come. So your expansion will be x squared minus x power 4 out of 3 plus 2x power 6 out of 45. Then other terms. So this is our sine squared of x. Members, let me know whether we are on the same page for that. Somehow, Dorcas, where is the problem? Dorcas, where could the problem be? Yeah. Okay, same page, yeah. So that's why now for this kind of series, you have to be very, very careful. To be very careful. And when you plot, you'll see that it is almost the same. So I know there are some places where you're going to reach, whereby they're going to just equate and say, sine of this is equal to this. So that is where it originates from. Are we good to continue? Same page. Okay, Dorcas says okay. Are we going to continue from here? Okay. Should we proceed? Okay. People are saying yes. Okay. I can now move on. Okay. Now, allow me to give you another one that I want us to try out. I want us to try out together. Okay, where is that number I want us to try out? So that is how you use the other knowledge to be able to get there. Even if they have told you to estimate, because sometimes we may be told to estimate, so we use the same what? The same procedure. So allow me to give another number and then we do the expansion. But I will allow you to first try it on your own, more so when you are dealing with those differentiation. So make sure that you have mastered that the differentiation bit of it, because everything is going to rotate around differentiation. Everything rotates around differentiation. Okay. Use the Maclaurin's theorem. That thing. Use the Maclaurin's series. Use the Maclaurin's series to write the expansion. Even sometimes they may use the word, they say write to 3 terms. Even if they have told you to write to 3 terms, then also you need to know where to end. Where to end. So use the Maclaurin's series to find f of x into 1 plus 2x up to and including the term in x power 4. Yes, and including the term in x power 4. So the first thing, you can first write your formula, no problem. So now you ask yourself, if I'm to reach to x power 4, it means you must be able to differentiate 4 times. 4 times. So I'm going to ask people to raise up their hands and they differentiate for us. I'm going to have 4 differentiations here. So the first one is going to be here. This is just f of x is equal to that. So the first one is Swabler. Yes, Swabler, give us the first differentiation. You tell us what to do to get the first differentiation. Swabler, you can unmute. Swabler?
Morning, sir.
Yes, good morning.
F of x is equal to root of 1 plus 2x, but it's the same as 1 plus 2x power a half.
Very good.
Then we drop the power,
Mm-hmm.
then we minus the power by 1.
Mm-hmm. So tell me what, right? I've dropped the power.
Into 1 plus 2x, then minus a half, power negative a half,
Mm-hmm.
then times
Mm-hmm.
2.
Okay.
So f of x prime will be 1 plus 2x power negative a half.
Mm-hmm. Okay. So, I want to stop there.
I give it in the second one.
Okay. Okay. It is okay. I thought you could simplify further, but it's okay. Can you remove that negative a half and write it in a better way?
Yes, it can be 1 over 1 plus 2x into power half, or 1 over root of 1 plus 2x power 1 plus 2x.
Okay, thank you, Sobra. Okay, can we have another one to take us through the second derivative? Another one, I want some, for the second derivative, we are going to start from here. Who is ready to take us through the second derivative? Okay, Wafula,
Yes, sir. Good morning.
morning.
So for the second derivative, we are going to drop the negative a half.
The negative a half.
Then we shall reduce the power.
May I just write what you told me there?
Yes, power negative 3 over 2.
Negative 3 out of 2, okay.
Then times 2.
Okay.
So we shall remain with negative 1 into brackets 1 plus 2x power negative 3 over 2, which we can simplify to negative 1 over 1 plus 2x power 3 over 2. Or further, negative 1 over root of 1 plus 2x in brackets power cubed.
Wow, thank you. Thank you, Elijah. Who's giving us the third? Who's giving us the third? So the third, we are going to start from here. Someone ready to give us the third? Okay, Jimmy. And then Ronald, you'll give us the last one.
We shall drop the power that is negative 3 times negative 1.
Okay.
Which is a theory. Okay. Then we reduce there by 1, which will be negative 5 out of 2.
Okay.
There we shall get 3 out of 2.
Have you differentiated what is inside?
Okay, sorry, times 2.
Times 2, okay.
Shall get negative 6 divided by 3. Okay. Into 2. Into 1 plus 2x. And then we shall lower the power. We shall lower it to make it a bit more beautiful. That is the 3 out of 1 plus 2x to power 5 out of 2. Which is 3 out of 1 plus 2x out of root 5.
Okay, thank you. Lastly, Ronald?
Morning, sir.
Yes?
Morning, sir.
Morning.
We are going to drop the power negative 5 out of 2. Then we subtract by 1, which is negative 7 out of 2. Differentiate what is inside, we get 2 times 2.
Okay.
Then we shall be having negative 15 into 1 plus 2x power negative 7 out of 2. We are having negative 15 out of root of 1 plus 2x power 7.
Okay, thank you. Thank you. So members, if you want, you can first differentiate everything of yours, and then after you put in the 0. So here we shall say f of 0. When you put in 0, you notice you have 1 plus 0, which is 1. Here, when you put in f prime of 0, you'll see that also you get 1. When you put in f of double prime of 0, you notice that you get your answer as negative 1. Here, if we put in f of 0, you notice we get our answer as 3. Here, if we put in f of 0, we get our answer as negative 15. Now, after doing so, we go back to our series. So when we go back to our expansion, remember we shall say now our f of x will equal to our f of 0 plus x f prime of 0 plus x squared f prime of 0 out of the 2 factorial plus x power 3 out of the 3 factorial f prime prime of 0 plus x power 4 f prime 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 of x out of 4 factorial, then plus plus. Then you substitute in. So when I substitute in, I'll have here my 1 plus my x. Then the next one is going to be minus x squared out of the 2 factorial. Then the next one is going to be my 3x cubed out of the 3 factorial. Then the last one will be minus 15 out of the 4 factorial, x power 4, then plus tan tan tan. So that is our series that you can go on and simplify. Whenever you have something up, proceed and do some simplification. So when I'm simplifying further, it means that this is 4. Okay, the first one will remain. So the first one will remain 1 plus x minus x squared out of 2. 2 factorial is the same as 2. Then here, where we have 3 divided by 3 factorial, this is the same as having 3 out of 3 times 2 times 1. This 3 cancels, so we remain with out of 2. So here, we shall remain with plus x power 3 out of 2. Then the next one is we have 15x power 4 divided by 4 factorial, which is 4 times 3 times 2 times 1. So you notice by 3, 1, by 3 goes here, 5. So you remain with 5 out of 8. So here we are going to remain with minus 5 out of 8 of x power 4, then plus ta ta ta. So that is your expansion. Okay, members, are we still on the same page? Are we there, everyone? Is it clear? Same page, clear. Okay, good, 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 good. It is clear. So you're going, let me write something here up for my reference. Okay, good to go. People saying we are good. Don't forget to put the continuity to show that there are other series that can come after. So let me come here. We are going to continue with that question. We are going to continue with that question. We are going to continue with that question. So I'm going to continue and say, hence, the question, hence, find an approximation. Find an approximation for the value of 1.02. Find an approximation for 1.02. Now here, you go back. Remember our expansion for 1 plus 2x. We have obtained our answer 1 plus x minus x squared out of 2 plus x power 3 out of 2 minus 5 out of 8 x power 4 plus. Now, if they want us to find an approximation for this, now always you have this one has to be written in this format. You write 1 plus 2x. We have 1 plus 2x. Now you have to express 1.02 in this format such that you just replace the x. So in the chat, tell me, how can we write this one in this format, or what will it be? Let everyone first try. Let everyone first try. Chiza, you can take a screenshot. Let me go back a step. Oh, Chiza, you can take a screenshot. So members, I want you in the chat to put, Dorcas has put some answer there. Thank you, Dorcas. Okay. So it should be in this form. Okay, so Dorcas, from Dorcas's submission, she's saying we find the value by equating. That is another person. Another person says we find the value of x by equating. So they are saying that 1 plus 2x, you equate that to. That one is very fine, members, as well. So you said 2x will equal to 1.02 minus 1. Then you said 2x is equal to 1.02 minus 1. You get 0.02, 0.02, divide by 2, divide by 2, and your x will equal to 0.01. So this is very okay, members. That means that when you come back, you are going to write our new function. We are going to write our new function in this format. There is a 1 plus 2, then our x is 0.01. That is the meaning. So what does it mean? That wherever we have x, we shall put 0.01. So we shall come and say 1 plus, in case you want, you can write it in a fraction form. In case you want, write it in a fractional form. If you don't want, write it like the way it is. So it's going to be 0.01 minus 0.01 squared out of 2 plus 0.01 power 3 out of 2 minus 5 out of 8 times 0.01 power 4, then plus what comes. Members, can you get the answer? Can you come up with the answer for that? Punch it in your calc and tell us which answer you get. Place in the calc and tell us which answer you're coming up. Why didn't we consider the power as we are equating? I'm not getting which power. Which power? Because remember, the power cancels. Even if you put the power, the power will cancel. Even if you wanted to put here, remember this is power half. And also what we are obtaining has a half. So these are halves do cancel as well. M. So we are punching the calc. Put the answer you are getting. Put the answer you are getting here and we see. Okay, some answers have come in the chat. 1.00995. Okay. 9. Okay. So you have 1.0099504 maybe something like that. Yeah. So what we do now, since they told us just an approximation, so you can, it depends in case they have to write such, in case they have not told us, then better we write it to at most 4 or 5 decimal places. So I can write 0.0995 as my answer, or even I can add on like that. And use an approximation sign. An approximation what? Approximation sign that you are just approximating. That is equal to that. But can you also place it in your calculator and see when you place the root of 1.02, is your answer close to that? When you place root of, is your answer close to that? What? Yeah, it is the one. It's the one. Yes, yes. Okay, yeah. Yes. So you may also find sometimes in case it is a number, they may even ask you to obtain the percentage error to find the error. So to get the error, you get the like the original value, get the new value you are getting through approximation, and then you find the way you do it in the other side of the other paper. The way you get your errors. The way you get your errors. Okay, same as. Okay. Are we going to continue? Okay. Oh, Jennifer. Okay, you're going to raise up your hand. Yes, Ronald.
So I would like to know whether it's was the binomial expansion or it's somehow different.
Oh, they are a bit related, but they are a bit related. All these expansions are a bit related, but different. In binomial, we don't differentiate. In binomials, we do not differentiate, but here we differentiate. But they are a bit related, but they are not the same. Okay, yes, Jennifer. Jennifer has put the hand down. Yes. Then Jennifer was asking about always your target, even when you are dealing with binomials, your target should be what did you expand to get what you have? When you look at our expansion, what we expanded had a 2x here. So we must take into consideration that for whatever thing we want to obtain similar to that, must have a 2 there. Must have what? A 2. Here, but if what we had expanded was just 1 plus x, then you'd have carried also your 2 there. But since it didn't have, then that's why we are ignoring it completely. Yes. Okay. So why don't you allow me to give you, do you need to do some more numbers? Or these ones you feel do we need to do more numbers, or you feel these numbers are fine? We can just have some exercise. Let me know through the chat. Let me know through the chat. On numbers and exercise. Okay, we can do one more. We can do one more maybe. Take an example. They can give you something like they can give you to expand something. Okay, they can tell you, let me say, they ask you that use the Maclaurin's theorem. Use the Maclaurin's theorem to show that e power negative x sine of x up to the term in x cubed is x out of 3 into x squared minus 3x plus 3. Hence, evaluate e negative pi out of 3 sine of pi out of 3. Now, since they have told us up to the term in x what? X cubed. So like we did last time, I'm going to break it and we have different people differentiate for us up to x power 3. So the first one is our function f of x, which is e of power negative x sine of x. Now, when you look here, you notice that you need the product rule. You need the product rule. So can we have the first person who is going to differentiate for us to raise up the hand? Who wants to differentiate for us? Okay, Ayob?
For the first one,
Mm-hmm.
we have f prime of x equals to negative e upon negative x sine x plus cos x. Yes, yes,
Like that?
yes.
Okay, thank you. Can we have another one to differentiate for us the next one? Eh, to differentiate for us. Who is ready to differentiate? Remember, we use the product rule, so we are going to use the product rule continuously. No one is ready to take up the challenge. Okay. Okay, Dorcas?
Good morning, teacher.
Morning.
Teacher, let me try.
We are going to?
Let me try. Okay.
Okay.
So
Mm-hmm.
we have E
We are going to
equals
have
to like E to the power
E.
negative E to the power negative
Uh-huh.
sine x.
I'm losing you. Are you are you differentiating this first?
Yes, teacher.
Okay. Can we first put this negative maybe a bit out here? Uh-huh. Continue.
Teacher, which one? You're saying this first one.
There is a negative here. Are you seeing that negative?
Yes,
Yes?
yes, teacher.
Oh, Your voice is a bit very low. I can't hear you well.
Yes, teacher.
Uh-huh.
Okay. Then sine x
Sine, okay, sine x, okay,
plus
plus
negative e power negative
negative,
e.
negative e,
Yes,
uh-huh,
power negative x
mm-hmm,
cos x
cos x, mm-hmm,
plus
plus
negative e
negative e,
power x
mm-hmm, mm-hmm,
plus
plus
e
e,
power x times
mm-hmm,
negative x
negative
sine x.
sine x, okay.
I'm going to collect like term.
Hey, collect like terms.
Okay. E negative sine x plus
Mm-hmm,
e power negative x minus sine x.
I'm not getting you.
Okay, I'm first collecting sine x to get
Okay, there is a negative here on this sine x. Here.
yes.
Continue.
Now I'm going to collect that force
Mm.
plus yes, negative e negative yes cos x minus e cos x.
Mm-hmm.
Now these two cancel down to sine x. E
Okay. Is this
negative
what you are ending up with?
yes teacher, that one.
Okay, thank you. Thank you. It is correct. Okay. Then thank you, Dorcas. Then the last one. Okay, the last one. Yes, Jimmy.
Okay, let's try. We shall
F.
have,
Mm-hmm.
we shall first keep out the 2.
Okay.
We keep it out.
Mm. I've kept negative 2.
Negative 2, okay. Then we differentiate. We shall have there negative x and negative 1 times e x power negative x. That one we differentiated it.
Mm-hmm.
Times cos x. Then plus e power negative x and was negative sine x.
Mm-hmm.
Then we shall allow the 2 to enter now.
Mm-hmm.
Then we have 2 e to power negative x cos x
Mm-hmm.
plus 2e to power x to power e, sorry, 2e to power negative x sine x.
Okay. Okay. Good. Good. Yes. Okay. So we are going to put in now our 0. F of 0, remember as you substitute is 0, sine of 0. So here we get a 0. F prime of 0, when I put in the 0, here is a 0, I get a 1. So for you, keep on substituting. When it comes here, f2 of 0, I'll have negative 2 e of negative 0 cos of 0. So I end up here with a negative 2. Then the last one, f of double prime of 0, I'll end up with a 2. Okay, members still on the same page? Bettina, where is the problem?
Lecture, for me, I request for pardon on differentiation from actually the second one, yeah, the first one.
Which one?
That one of f prime,
This one?
yes,
Okay. Do you know the product rule?
yes.
How does it state?
U into dv dx
Mm-hmm.
plus v du dx.
So here, you just name, if our u is e power negative x, what is our du dx? Differentiate this exponential. What do you have?
I didn't attend that lesson of explanations.
Now that's where you have to go now back and first watch, because here you
So
differentiate this,
I didn't understand.
you differentiate this first, and you get negative 1. Then after write the exponential the way it was. Differentiate the
Oh,
power on the exponential. The answer you get, put it here, then write the original thing.
yes, teacher.
What about when you differentiate sine x? What do you get?
I get cos x.
Cos of x. So your u is e power negative x. Dv dx is cos x. Your v is sine x plus sine x. Your du dx is negative e of negative x. So that's how we got this.
Yes,
Is it fine?
yes, teacher.
Yeah. But you can go back and review from the first steps such that you learn how to differentiate those exponentials. Okay, so members, now we are going to write our function again. So our function is going to be f of 0 plus x, f prime of 0 plus x squared, f prime of 0 out of the 2 factorial plus x cubed, f prime of 0 out of the 3 factorial, then plus. So you substitute in. Your f of 0 is 0. I don't need it. So I'll have my x, the first one. Then the next one is going to be x squared. Then our f prime was negative 2. So I say minus 2 of x squared out of the 2 factorial. Then the next one is going to be 2. So it's going to be 2x cubed out of the 3 factorial, then plus. But when you look at the format, they wanted you to write it. They wanted you to factorize out. So you come back again. First substituting your 2 factorial and 3 factorial. So, and I told you whenever there is a 2, you remove it. So, in case there is something you can reduce. So, 2 divided by 2 factorial, sorry, this is just x. Okay, let me write here now. So that one, we are going to have x minus x squared. Then this is going to be plus x cubed out of 3. Because we want to put it in this form, because remember, 2 out of 3 factorial is the same as 2 out of 3 times 2 times 1. The 2 cancels and remain with 1 out of 3. So that's why we have this. Then 2 out of 2 factorial is the same as 2 out of 2 times 1. The 2 cancels and you have out of 1. So that's why we have out of 1. Then from there, it is your mathematics that is going to work out for you. They want you to have x out of 3 out. So that means that if I'm to take x out of 3, what am I going to remain with? You ask yourself, what am I remaining with here? So in simple terms, when you factor out something, let me start with this. Let me say you have x squared plus maybe 2x and you have factored out x. So to get what remains, always get this thing inside, which is x squared, divide by what you have taken out. So for such a case, here where we have x, we have taken out x out of 3. I'll have what I have inside divided by x out of 3. So this x and the x cancels, so this is the same as x divided by x out of 3, which is x times 3 out of x. The x cancels, so here we remain with 3. Then for this second part, I'll have x squared divided by x out of 3, which is x squared times 3 out of x. 1x and 1x goes, so you'll get x times 3, which is 3x. So here, we shall remain with 3x. Then for the last one, still you do the same. X squared out of 3, sorry, x cubed out of 3, then divide by x out of 3, which gives us x out of 3 out of 3 times 3 out of x. The 3 cancels, 1x reduce, here remain with 2. So here we shall remain with x squared. So that's how we are getting there to the answer. So at this point now, allow me to say that now our whole thing is going to turn into x out of 3. You organize it the way they gave it to you as x squared minus 3x, then plus the 3. So that is how we get at that point. Are we still on the same page? Any questions at this point? Anything you feel we need to throw more light on, or it is clear? Okay, people are saying yes, we're on the same page. Now, at this point, where we have reached, we have got what they wanted. Okay, let me first pick on yes, Shadow.
Teacher, I failed to understand how you differentiated the f prime prime x.
F prime prime. Here.
Yes.
We
No,
use the
this one here.
product rule.
Okay.
Your u is this, your v is this. So just because this is a constant, I just pulled it out. But if you want, you could keep it as your u.
Okay. Thank you, sir.
Okay. Whenever you find two functions in the same variables, apply the rules. Apply the rules, whether it is, yes, apply the rules. Then they told us that hence evaluate this. So what do they mean? It means from what you have obtained, go on. So now, when you check, you can notice that our x, when you compare your x, members, what is the x? When you compare, what is our x? What is the x we are going to use such that we substitute in this Maclaurin's theorem? Compare what you have expanded. Remember, at the end of the day, what we have expanded, the whole of this a of negative x sine of x out x is the same as x out of 3 into x squared minus 3x plus the 3. Very good. It is pi out of 3. So that means we shall just come and say e of negative pi out of 3 sine of pi out of 3. Where there is x, we put pi out of 3. So we shall have pi out of 3 divided by 3 into pi out of 3 squared minus 3 times pi out of 3, then plus 3. So, then you work out the math. Feel free to place in your calculator and then come up with the answer. You just place for us the answer you're getting in the chat. I know it's going to be in points. It is very well. Place your calc and come up with the answer in points. Place your calc and then we get the answer. Okay. Bettina?
Also, it's another thing I have an inquiry. Here, as we are expressing functioning, just think of x out of 3 into x squared minus 3x plus 3. So I don't know how, because previously we had this thing of x minus 2x squared out of 2 factorial, then plus 2x cubed out of the 3 factorial. Then as we go to this, I have not understood how the signs have changed to have x squared. Yes.
Like here, are you saying this is what we had, right?
Yes.
So when you have 2 out of 2 factorial, x squared, 2 factorial, when you place the calculator, which answer do you get?
Which is that 2.
The 2, x squared. So these 2's can reduce.
Then we came up with x minus x squared plus x cubed out of 3.
Yes, then this second one is 2x cubed. What is 3 factorial here?
It is it? Is it 6?
6. So you say by 2, 1, by 2, 3. So that's how we got here.
Like kind of like as we are pulling out the x out of 3.
Oh, now the x out of the 3, it is because the question pulled it out, what they wanted us. So also, we had to pull it out. Now, when we pull it out, like I told you, whenever you pull out something, x out of 3, and for us, initially, we had x minus x squared plus this. So get this thing you have remained with, x, divide by what you have pulled out. So which is x? Divide by x out of 3, which is x times 3 out of x. So this and this cancels. So for us here, we remain with a 3. Then you go to the next one as well. You say x squared divide by what you have pulled out, which is x squared times 3 out of x. The x cancels, you remain with 3x. So here, we shall remain with minus 3x. Even the last one, where you remain with just your x squared. Then you can arrange them by starting with the highest power, go to the next power, and then the other power. Is it clear?
I've
Not
got,
yet?
yes, I've got it.
Okay. Members, which answer are you getting? I'm not seeing anyone committing to the answer. Okay. 4 point. Linda, can you place the calc again? Linda, let's place the calc again. Okay, yeah. Lydian, that's okay. Jen, that's okay. At least those answer the 2. Samuel, that's okay. Okay, so members, even me here, I do get those answers of 0 point. So here, my answer I get when I press my calc is 0.333368379. That is the answer I get. So which I can write to 4 or 5 decimal places. So I say approximately 0.33338. Okay. Yes, yeah. That answer is very okay now. That answer is very, very fine. Okay. Okay, members, are we good to go? I want to just give you some few numbers to try out. Good to go? Can I give just straight 2 numbers for us to try out? Okay. Now our exercise, we are going to try out. Oh, I have not showed you. Oh my God. Oh my God. Yeah, but if you recall very well, let me just show here roughly. Yes, sometimes when you are differentiating things from first principles, one time someone asked about, I think we are differentiating something from first principles, and then like the person asked me, what if I put in this kind of series? Now, those different series we do have, they originate from this side, they originate from this side. An example maybe I wanted to give was for, let me say you have y is equal to an exponential of ax, and you are differentiating it from first principles. So from first principles, what will you do? You say y plus change in y is equal to a, then you say x plus change in x. Then you say change in y will equal to this a into x plus change in x minus y. Then change in y is equal to this a into x plus change in x, then minus e of ax. Now here you can factorize out. You say aax is equal to e. This will be what? Will be a change in x minus a 1. Something like that, eh? Now, for such, if you know how to deal with this, you can apply those series. You can apply those series. Just a rough one. When I have a small change in x and I'm expressing it in the series format, you will notice that in series format, like in the other Maclaurin's theorem part, you have f of 0 plus f prime of 0. Okay, this is x, then plus f prime prime of 0, then there is an x squared out of 2, then plus plus plus. Now for such a case, when you put f of 0, you'll get your 1 plus your x. Now for this particular one, what your x is, you ask yourself, what is my x? You check out here what you are dealing with. So now that is something you can try out maybe in your free time. Because when you differentiate, that's some kind of expansion I want you to try out. So you'll find out that in that expansion, you end up with something like this. Then this is like x squared changing x squared out of 2 plus like that. So here, that's where they get that thing. Those who were just getting it. So they get it from here and they substitute this pi. So someone just substitute in here. It says now minus 1. This one and this one cancels. Then this is for bigger variables. It cancels. So you remain with a change in x. So that's why when you are using this approach, here you say a change in x, e of x. Then you continue. Yeah, but that one I was just showing you to show you where you can apply them. But that one should be your research work. In your free time, you can go and then you read further about it. Okay, now this is our exercise. Number one, I have natural log of 1 plus x out of root of 1 minus 2x. And what are you showing? Show that you get 2x plus x squared out of 2, then plus 5x cubed out of 3, then plus plus. Then the second one I have for you, is number 2, 1 out of 1 plus x, to show that your answer, still we are using the Maclaurin's theorem, that you get this. Also, then the third one is going to be tan of x, and show that tan of x you get x plus x cubed out of 3 plus plus plus. I think those ones will be enough for us to try out and then see what we come up with. Unless someone has a question, but the key thing is, do you know how to differentiate? Yes. If you know how to differentiate, then other things will become very easy. But also maybe let me add, what about when you have e exponential of x? Can you show that you get something like this? And so on. Yeah. Unless someone has a question. But these are the numbers I want you to try out using the Maclaurin's theorem. And then, yeah. Any questions or we are good to go? In case there is any question, we shall end here for our session. And thank you so much for attending. We shall meet tomorrow.